Hello and welcome to this video. This is the second lesson for Chemistry 20 in the bonding unit. In the last lesson, if you remember, we looked at ionic compounds and we looked at the steps for drawing the transfer of electrons from the metal to the nonmetal, how they would then have ion charges, so we put square brackets around them. Today we're going to focus on covalent bonding. Covalent bonding is what happens in a molecular compound. Okay? And they do not transfer their electrons, they share their electrons. Okay? They share a pair of electrons or more. They can actually share 2 pairs and 3 pairs, making double and triple bonds. Okay? So we are no longer dealing with ions. We are no longer dealing with ion charges. These are also sometimes called Lewis structures rather than electron dot diagrams. So instead of transferring, we are sharing electrons. Okay? The electrons that are being shared are making what we call a bonding pair. And like I said, you can share 2 pairs or 3 pairs, making double and triple bonds. So a double bond would have 2 pairs. 2 pairs would mean we have 4 electrons in total, and that's a double bond. And then 3 pairs would be 6 electrons in total, and that is what we call a triple bond. Okay, so we'll look at the steps of drawing these and then look at how we get into double and triple bonds. So you start by putting the atom in the center that has the most bonding electrons. Okay, so remember the bonding electrons are the unpaired electrons. Usually it's the first element listed in the formula for your molecular compound. You then arrange everything around as symmetrically as possible. The exact in terms of symmetry, it doesn't mean it has to, I'll go through examples and show you what I mean for symmetry. It's just if you have more than one central atom and you have, let's say, 4 terminal atoms, you're going to put 2 terminal atoms on each central atom to make that symmetrical. That's kind of what that means. Okay? And then you're going to share electrons, making sure everything has 8, with the exception of hydrogen needing 2. Now, if you have unpaired electrons left over after you've placed everything around as you can, that's when double and triple bonds are made. So let's look at some examples. Let's start with pH3. So my first element listed is phosphorus. Now, I'll just quickly draw phosphorus on its own because this is kind of what you have to be thinking about in your head when you're drawing these. What does my phosphorus look like as an atom? What do my hydrogens look like as atoms? Again, the number of dots come from the group number. So phosphorus being in group 15 has 5 valence electrons, 3 of which are bonding electrons, and each hydrogen has 1 bonding electron being in group 1. So phosphorus has the most bonding electrons, so I'm going to start with phosphorus in the middle. Now, where the electron on the hydrogen goes, remember in the first video I said it can go on any of the 4 sides. It doesn't have to go in the top. So maybe for one hydrogen, I'll, like a puzzle, move it with its 1 electron like that on the top. But another hydrogen, I'll put its 1 electron on the left-hand side so that it pairs up with one of phosphorus's bonding electrons. And the third hydrogen, I'll put with one of its bonding electrons on the right-hand side, pairing up with phosphorus's electrons. Okay, so now if I look at how many electrons I have around each atom, my phosphorus has 8 electrons around it. And each hydrogen has 2 electrons around them. Hydrogens only need 2. Everything else needs 8. Okay? So you don't have to do them in different colors. It's just to show you the electrons. It's like a puzzle and how you fit it together, pairing up the bonding electrons. There will never be a hydrogen or another element there because that's a lone pair. It's already paired up and stable. We don't go beyond that, okay? So wherever you have a lone pair, you never pair anything or put anything, any element up there to be shared with it. So let's look at some other examples. And by the way, I did mention the term central atom. When you have more than 2 atoms in your molecule, the one in the middle is the central atom. So in this case, that would be the phosphorus. And the H's on the ends are called terminal atoms. This terminology is going to come up a lot. You can have more than one central atom as well, which we'll look at today, but this terminology was going to come up a lot throughout this unit, so it's important to note, again, when there's more than two atoms, one of them's in the middle and the other ones surround it. So the one in the middle is called the central atom. So if we look at some other examples, HCl. So H has one bonding electron. Cl is in group 7, so it has 3 lone pairs, and I put the lone pairs on the outsides, and 1 bonding electron. I put its 1 bonding electron there. Now here I have only 2 atoms, so there is no central atom. They're both terminal atoms. The H and the Cl are both terminal atoms. Okay, my Cl has a full 8, my hydrogen has 2. Let's move on to CH4. Carbon will always be your central atom if it's the first element, because 4 is the most bonding electrons you can have. So around each orbital, I'm going to add another hydrogen, up to 4, right? CH4 means there's 4 hydrogens. Okay, so that's what that looks like. And I have my carbon as my central atom. The H's are all terminal atoms. Fluorine. Now fluorine also has 7 valence electrons, being group 17. So I'm going to put one of my fluorines with its bonding electron on the left-hand side, but my other fluorine I'm going to draw with its bonding electron on the right-hand side, and the lone pairs, the 3 lone pairs on the outsides. Because I never pair up a lone pair, I'm just pairing up those unpaired bonding electrons. Okay? And then NBr3. So nitrogen has 5 electrons, valence electrons. 3 of them are bonding. So the nitrogen will go in the middle because my bromine only has 1 bonding electron and 3 lone pairs that go on the outside. Okay, so there's 1 bromine. Here's another bromine with its 1 bonding electron, and then 3 lone pairs on the outside. And my last bromine with its 1 bonding electron and 3 lone pairs on the outsides. Okay, that is NBr3. Now, let's get into double and triple bonds. Okay, C₂H₄. I have 2 carbons and 4 hydrogens. When you have more than 1 carbon, you're always going to start by pairing them up in the middle. So I'm going to have 2 central atoms here. 2 carbons, they're each central atoms. This is where the symmetry part comes in, where I want to put everything as symmetrical as possible around it. If I put a hydrogen on the left-hand side of the purple carbon, I'm going to put a hydrogen on the right-hand side of the red carbon. If I put a hydrogen on the bottom of the purple carbon, I'm going to put another hydrogen on the bottom of the red carbon. Okay, each hydrogen bringing 1 electron with it. Now I've placed everything, my 4 hydrogens and my 2 carbons, around my central atom. What I have left, carbon purple has a bonding electron and carbon red has a bonding electron. Okay, if you have 2 neighboring atoms, each with a bonding electron left over, those electrons actually move in the middle to make a double bond. Okay, so I'm actually going to erase them, erase the purple electron up here, erase the red electron there, and I'm putting them in the middle to form a double bond. There's 2 pairs, or 4 electrons in total, which makes a double bond. Same with C₂I₂. I have 4 electrons around each carbon. They're all bonding electrons. So again, I'll start by pairing up one of their bonding electrons in the middle to start. Now this time I only have 2 hydrogens. So I'll put 1 on that end and 1 on the the purple carbon on the other end. Now I have more leftover bonding electrons. So these ones will move in the middle and these ones will move in the middle. Okay? So if I erase all those and move them in the middle, carbon had 3 electrons, 3 bonding electrons that it put in the middle, the red carbon, and the purple carbon, the same thing, had 3 electrons in the middle. Okay, so there's 6 electrons or 3 pairs being shared between them, making what we call a triple bond. Now, before we finish this lesson, we're just going to look at converting a Lewis diagram, which is what we just learned how to do, into a structural diagram. Okay, so a structural formula or diagram is where we replaced shared pairs of electrons with a line, and we include the lone pairs only on the central atom, because the central atom in the next lesson is going to be how we determine the 3D shape that the molecule takes. Okay, so what that means is I have to only keep it on the central atom to see, because it's going to affect what shape it takes. So the terminal atoms, you don't need to keep the lone pairs on. So if we go back for a second and I write the structural diagrams for all the formulas we've already written, HCl, there's no terminal atom. Sorry, there's no central atom, so I'm not keeping lone pairs on either of them. I only keep lone pairs on central atoms if they have lone pairs. So the lone pairs around the chlorine are not shown. There's a single line between the hydrogen and chlorine because they're sharing 1 pair of electron. Same with CH4. There's a single line between the carbons and hydrogens, and there were no lone pairs on the carbon, so no dots. F2, 2 terminal atoms, so I don't show the lone pairs, a single line between them. Now, NBr3. This is where I leave the lone pairs on the nitrogen only. I don't need to put it on the bromines, they're terminal atoms, but I need to leave it on the nitrogen because it's going to affect the shape that this molecule takes. Okay? Again, single lines representing single bonds. What does it look like when we have double bonds? Now I have 2 lines between my carbons because there was a double bond. There was 4 electrons there, and then single bonds to the H's. Same with this molecule, but now I have a triple bond, so 3 lines between the 2 carbons and single lines to the H's. Okay? So when you are drawing structural diagrams, only keep lone pairs if it's on a central atom. If a central atom has lone pairs, carbons never have lone pairs, okay, because all of them are bonding electrons. And then again, the number of pairs is the number of bonds, the number of lines you'll draw between them. Okay, so that is it for this lesson. Thank you for watching.